Hi, everybody. My name's Guillaume Mauger. I'm the Washington State Climatologist and a researcher in the UW Climate Impacts Group. And I'm here to talk about the ways that climate change is affecting flooding in Washington. So I want to start by talking about the three drivers of changes in flooding in Washington. And then I'll go into depth on each of these. So the three are first, declining snowpack. Second, heavier rain events. We expect rain events to become more intense. And third, sea level rise. All three of these are combining to make flooding happen more often and to make floods bigger in many of our rivers across the region. All right, so the first one, snowpack. This is a little bit of an unintuitive one, but what's going on here is that if you can imagine if you have less snow, you've got more rain. And if you've got more rain, when you've got a storm event, that extra rain can end up in your rivers and make bigger floods. So we like to think about it in this way that the drawing is showing where the snow line's going up, and that means you've got more area that's seeing rain, leading to bigger floods. So snow is kind of the canary in the coal mine in terms of climate change in our region. We've already seen about a 25% decline in spring snowpack since about 1950. And then looking forward, we're expecting about a 55 or at least a 50% decrease by the end of this century. So accelerating decline in the future because we're seeing accelerated warming in the future as well. But like I said, we've already seen big changes in snowpack. It's likely already affecting our floods, and I'll show you one example about that in a moment. The next one is heavy rain events. So in our region, when we get big rain events, in Western Washington and in Eastern Washington, it's almost always an atmospheric river event. That's what we call them. Um, this is one where studies up to now aren't really detecting a trend so far. So we really haven't seen a big change, if any, in these. But looking forward, the models are showing an increase, and they especially show an increase after the middle of this century. So this is one that we're sort of expecting to emerge later, mostly in the second half of this century. What the models show is about a 20% increase by the end of this century in the amount of rainfall we get during those events. So one thing that's important to note here is the models aren't showing big changes in the number of events coming off the Pacific, the strength of their winds, how deep the low pressure is. Those things on average are pretty much staying the same. The big thing that's changing is we just have warmer air. Warmer air holds more water. That means you can rain more out, even if the storm characteristics are otherwise pretty similar. So that's heavy rain events. And then the last one, if you're near a coastal area, that is sea level rise. So that's another one where we have seen a clear trend over the last century. On average for Washington's coastline, it's been about 4 inches of sea level rise since the 1930s. That's varied across our coastline because we live in a tectonically active region. So it's more in Seattle and it's less on some parts of the outer coast. And then looking forward, this is another one that will also accelerate. So by the end of this century, we're expecting 1.5 to 2 feet on average in sea level rise. And that range is, again, because of those tectonics, right? This photo is showing a king tide event happening at the same time as we have a low pressure coming over. This is a picture of Alki Beach in Seattle. And you can see the water's over the top of the staircase. This is kind of like a preview of what the future high tides would look like when it's not a king tide and there isn't that low pressure to sort of bring the water up extra high. All right, so those are the three factors. Like I said, they're all contributing to make flooding worse. But what does that actually mean when we start to look at, what gets flooded and when? So I want to show you a few examples to help illustrate what we're expecting. The first, I think it's always helpful to look at a recent event, and there was a really tragic, catastrophic flood that some of you may remember on the Nooksack River in Whatcom County back in 2021. This is a picture of that flood looking downstream towards Bellingham and Ferndale and the Lummi Peninsula. And you can see a lot of flooding happening there. This was a big atmospheric river event. So really the big story here is the whole watershed upstream of this area just got a lot of rain, right? And that led to flooding downstream. Folks have looked at what might have caused this, and the study out of British Columbia that looked at this in terms of the climate change impacts found that climate change made this storm 2 to 4 times more likely. So we probably still would have had flooding without climate change when this event happened, but it was a lot bigger because of climate change. And I think the most likely reason for that um, is that we've got less snow than we used to, like I was telling you earlier, which meant we had more rain and less snow when that atmospheric river hit the watershed, and that meant more rain coming downstream and into the floodplain. All right, another example is looking at flooding in the Skagit Valley. What we're seeing here is a computer-generated image showing what the water level would be in the Walmart parking lot in Burlington. So this is in the Skagit Valley during today's 100-year flood. So like I said, this computer generated, right? This flood didn't happen, but this is the level that the model shows the water would be at if we had a 100-year event today. And this is from the latest modeling from the latest set of FEMA maps that were developed in the mid 2000s. So you can imagine all the consequences that would happen here, right? Just like we saw all of those catastrophic consequences in the Nooksack. If this happened today in the Skagit, right, this is just one example of the kinds of impacts that there might be. And it's a reminder that even if we ignore climate change, we're not always very resilient to today's conditions, right? Today's floods in this case. And what climate change does is it just accelerates the change and makes that even more important because those floods are getting bigger and happening more often. So, for example, our modeling shows that by the middle of this century, just a couple decades away from now, that 100-year flood that you're looking at would become more like a 22-year event on average, right? So that means it would be happening about 5 times as often, right? So it'd be 5 times more likely to see a situation like this than it is today. A related example is in Olympia, where uh, we see the same thing in terms of coastal flooding. So here we're looking at sea level rise. The picture you're seeing is a king tide event and how it's flooding a parking lot in Olympia with the state building, the Capitol building behind there. With 6 inches of sea level rise, we'd see the 100-year version of this. This is just a king tide. It's not a 100-year flood, but 100-year flood would be worse, you can imagine. We'd see that go from a 100-year event to an 18-year event. So again, happening about 5 times as often, right? So in both cases, we're expecting climate change, even small amounts of climate change, right? We're expecting 6 inches of sea level rise to happen in just a few decades, right? We'd have these problems, these floods happening a lot more often. I want to end on a more positive note, which is to say that we can learn a lot about how we could be more resilient by just looking at these events and what went wrong and what could go better when they happen, right? So we all do that. That's already happening. We have a lot of agencies and municipalities that are actively working on these on tracking what happens and what could be improved. And I think we could do more of that.